Welcome to Saucy Math. Today we're going to talk about the real number system, which is basically just the types of numbers that we have. So the first type of number that we have is what we call the natural numbers, which are the numbers that you learned first when you were like 2 or 3 years old and you learned how to count on your fingers, 1, 2, 3, 4, 5, or however many fingers you happen to have. All right, so the natural numbers, I'll just write them in there, 1, 2, 3, 4, 5, and so on. I'll just stop at 4. All right, so those are the numbers that you just use for counting, right? So we call those the natural numbers. Now, the next biggest group of numbers outside of the natural numbers are what we call the integers. Right, so notice that the natural numbers are within the box for the integers. Right, so everything that is a natural number is also an integer. Right, but the integers include more numbers besides just those natural numbers. And what the integers include are these positive whole numbers here, the natural numbers, but also the negatives of all those natural numbers, and also the number 0. Right, so integers, we add in the number 0, and then also the negatives, -1, -2, and so on. Right, so all those numbers are the integers, basically the positive and negatives whole numbers, and then also 0 thrown into the mix. All right, so those are what we call the integers. Now, the next biggest group outside of the integers are what we call the rational numbers. Right, rational numbers, if you think of like what that word actually says, right, it has the word ratio in it, and a ratio is a comparison of two numbers, kind of like a fraction. Right, so rational numbers are numbers that you can write like a fraction. Right, so all of the integers and natural numbers are rational numbers because you could take any one of these numbers and write it as a fraction. Right, you can write 4 as 4 over 1. Right, you could write -2 as -2 over 1, and any one of those could be made to look like a fraction just by putting it over 1. Right, so all these integers and natural numbers are also rational numbers, but the rational numbers include a lot more numbers besides just those integers. All right, the rational numbers like 1/2, that would be a rational number. A number like 4 1/3, right, a mixed number, which you could convert into a fraction if you wanted to. Also decimal numbers. Decimals that are what we call terminating decimals, so decimals that stop, something like 1.27, right? That would be a rational number because you could convert that into a fraction. But also repeating decimals, so a number like maybe -5.379 repeated. Right, so it'll be like -5.379, 379, 379, that just keeps on going like that. That number also could be written as a fraction. It's a little bit trickier to do that, but a repeated decimal, a terminating decimal, right, one that stops, mixed numbers, fractions, all of those are examples of rational numbers. All right, and remember, the integers and the natural numbers are also rational numbers. All right, now that leaves another category of numbers which we call the irrational numbers. Right, irrational, and if you know how a language works, that E or IR in front of it means not rational. Right, so the irrational numbers are numbers that are not rational, numbers that you cannot write as a fraction. Right, and also notice that the categories here are completely cut off. Right, the natural numbers are within the integers are within the rational numbers, but the irrational numbers are a completely separate group. Right, there's no overlap there at all. Right, so a natural number or an integer is never going to be an irrational number. Right, they don't really mix. Right, so irrational numbers are, like I said, numbers that can't be written as a fraction. Basically, they're decimal numbers where the decimal just keeps on going forever, it never stops, it never repeats itself in any kind of pattern. That's what we call an irrational number. So you see irrational numbers a lot with square roots. So a number like the square root of 2, that's an irrational number. Right, if you put that into a calculator, it gives you a long string of decimals, and your calculator will give you, I don't know, maybe 10 decimal places or something like that, but that's not the whole thing, right? That decimal number is going to keep on going forever with no real pattern to it. So something like the square root of 2, the third root of 10, right, that would be another irrational number. Ooh, a number like pi is an irrational number. All right, so irrational numbers, basically anything that involves pi, or a lot of numbers that are inside roots, are what we call the irrational numbers. Right? You cannot write those as a fraction of integers, basically. All right, so those are the types of numbers. Now, you won't see a lot of problems where you're asked, is this number a natural number? Is this number an irrational number? But these words will come up in some problems. Like some problems might say, the domain of this function is the set of integers that are greater than or equal to 0. And when you see that word integer as part of a problem, you just need to know what they're talking about, right? Which is why it's important to know these different categories of the numbers. All right, so just a couple examples here of what type of number we have. All right, so a number like negative 7.2, all right, so it's a decimal number, right? But the decimal stops. It's a terminating decimal, which means that it's a rational number. All right, so negative 7.2 is what we would call a rational number because it's a decimal that stops. All right, it doesn't matter if it's a positive or negative number, right? Rationals could be positive or negative. All right, the next number we have here is square root of 12. All right, so we see that square root, that makes us think right away that it's probably going to be an irrational number. And if you try to figure out what the square root of 12 is, it does not come out to a nice whole number or a nice, rational number, a nice fraction. It comes out, if you put square root of 12 into your calculator, to a long decimal. When you see something like that, that's going to be an irrational number. All right, so square root of 12 is an irrational number. 9 over 2, right, so that's a fraction. If it's a fraction, it's automatically going to be a rational number. All right, so we know 9 over 2 is going to be rational, but remember, rational numbers contain other categories. They also contain integers and natural numbers. So just because 9 over 2 is a rational number, well, maybe it could be one of those other ones as well. So we have to figure out what 9 over 2 is equal to, and if it equals a whole number, then it would also be an integer and a natural number. All right, but what's 9 divided by 2? All right, that's 4 1/2 or 4.5, which is not an integer, right? It's not a natural number because it contains a decimal. So this one is just a rational number, right? It's not one of those other categories. Next one we have is square root of 25, which is a square root, so it looks like it's going to be an irrational number. But let's think about it before we just write down irrational. All right, square root of 25, what does that equal? Well, the square root of 25 is 5, right? Because 5 times 5 equals 25. So since we could rewrite the square root of 25 as 5, well, now 5 is a natural number. Right, it's one of those numbers that we use when we count on our fingers, which means if it's a natural number, it's also an integer, and if it's an integer, it's also a rational number. Right, so the square root of 25, even though it looks like an irrational number, it's not. It's actually all those other three categories. All right, so remember, since what we had over here, the natural numbers are within the integers and within the rational numbers. So if a number is a natural number, like this one, the square root of 25 turned out to be 5, that means it automatically is also going to be the integer and a rational number. Right? It's going to be all three of those, right? Even though it looks like an irrational number because of the square root there. And a lot of times math teachers give you those just to try to trick you to make sure you're paying attention to what's going on. So just look out for that. All right, the next number we have is pi over 2. Basically, anytime you see pi involved in your number, whether it's just pi by itself or pi and some other number being operated with it, that's going to be an irrational number. Right, and you could put into your calculator pi divided by 2, and it'll give you some long decimal thing. It's like 1.57 something. I don't know exactly what, but that's going to be an irrational number. All right, the next one we have 2.222. All right, so that's 2.2, and that 2 after the decimal point is repeated. All right, so remember, repeated decimals are rational numbers. All right, so if your decimal is repeating, it's a rational number. If the decimal doesn't repeat, that's when it becomes irrational. But since this one contains a decimal, this one's not going to be an integer or a natural number, right? It's just a rational number. And the last one we have is negative 30 over 6. All right, so negative 30 over 6, it's written as a fraction, so that tells me right away that it's going to be a rational number. All right, anything that's written as a fraction is automatically a rational number. But could it be one of those other categories? Could it be an integer or a natural numbers which are contained within the rational numbers? Well, let's think about it. What does negative 30 over 6 equal? Well, 30 over 6 is 30 divided by 6, which divides evenly and equals 5. So negative 30 over 6 equals negative 5. Right, so it turns out to a negative whole number, which is an integer. Right, when we divide that, we don't end up with a decimal. We end up with an integer, negative 5. Right, but since it's a negative 5, it's not a natural number. Right, remember the natural numbers are just the positive whole numbers, 1, 2, 3, 4, 5. Right, negative numbers are not natural, they're just integers. All right, so negative 36 turns out to be, negative 30 over 6 turns out to be a rational number and an integer. All right, so that is a few examples of the types of numbers in the real number system. And like I said, you won't see a lot of problems like that where you're asked to put numbers into categories. This is more of a thing where you just need to recognize when you see them talking about irrational numbers, what that actually means.